Okay, so now we're going to think about how that odds ratio is related to the slope, beta 1, in that logit form of the logistic regression model. So remember, in the logit form we have log odds is equal to beta naught plus beta 1 times x. And if we try to interpret the slope the way we normally would in a regular simple linear regression, that is the expected change in the response when the predictor, value of the predictor, increases by 1 unit. But in this case, what does that actually mean? We're talking about the typical change in log odds when the explanatory variable increases by 1 unit. That's kind of an odd, I guess I shouldn't use the word odd. It's a little bit weird. I don't know what that really means. So we're going to see if there's a more useful way to understand the meaning of that slope. And then also we have a question about what if the explanatory variable is binary, because to have a single increase, unit increase in the explanatory variable, what does that mean when your explanatory variable just has 2 outcomes? So we're going to go back to the migraine example and try to understand this. And I have a definition here for the empirical logit, which just means that you're computing odds based on the sample data and then finding the log odds based again on the sample data. Okay, so example 4 is back to the migraine example. So I created another table here. We've computed much of these things. We already computed the odds for being pain-free after 2 hours in the TMS group and the placebo group. We computed the odds ratio to 0.27 by taking 0.639 divided by 0.282, so the ratio of the 2 odds values. Then I have here the log odds values, which again, if you want to pause the video for a moment and take the natural log of 0.639, you'll get negative 0.447. If you take the natural log of 0.282, you'll get negative 1.266. Then I have the slope written in here of 0.82. Let's see if we can understand where that comes from. So I have some R code here for computing the log odds and adding that variable to the migraine data set, and then computing the slope. Let's see if we can figure out how to do that. So I've created a graph here, and I put a group code variable into the migraine data set. So I gave the TMS group a code of 1 and the placebo group a code of 0. So in this picture, I have a point at 0, negative 1.266. That's, so if you notice on the vertical axis, the label, it's the log odds of being pain-free, right? So that's negative 1.266 for the placebo group. And my second point over here is at 1, negative 0.447. So negative 0.447 is the log odds of being pain-free after 2 hours for the TMS group. And so if I actually compute the slope between those 2 points, I can take change in y over change in x, which is a nice easy 1 minus 0. And you'll see that that actually is where the 0.82 comes from. I'm really doing negative 0.447 plus 1.266, or as it says in this code right here, right, I'm taking the log odds for the TMS group minus the log odds for the placebo group, and that comes out to be 0.82. Okay, now that's all well and good, so we found the slope, but how can we actually interpret that? So we just got done saying that that fitted slope, that rise over run, well, we're going to have a run of 1 when our explanatory variable is binary categorical. We have a change in log odds over 1 minus 0, or 1. But in fact, if we look at this, right? So our fitted slope, let's just do this generically instead of this with this. I mean, we just did it for this example, but let's think about it generically. Our fitted slope, if we take the log odds from group 1 minus the log odds from group 0, and now I'm going to stop writing 1 minus 0 because we all know that's 1. If we actually use the properties of logarithms, that's the log of the odds of group 1 over the odds for group 0, odds of success for group 0. So this, in fact, is the log of the odds ratio. That's what my slope is equal to. It's the log of the odds ratio. So that means that the odds ratio is actually e to the fitted slope, right? If I want to solve that for the odds ratio, I exponentiate both sides. So the odds ratio is e raised to the fitted slope. So when you create one of these logistic regression models and you look at that slope value, if you exponentiate it or raise e to that slope, that'll get you the odds ratio. Now, one other thing is that when you create the logistic model in R, because of the way the data was summarized in that migraine data set, we've changed our syntax a little bit in the GLM command to accommodate that. Okay, so when the data were in that two-way table, then we have this cbind command at the beginning of the GLM command there. Okay, so again, in this summary, I have a little note underneath here. So our slope of 0.82, we can see there. Now, the intercept is the log odds for the placebo group. So if you think about group TMS having a value of 0, that means the person was in the placebo group. And of course, the output of this logistic regression model is log odds of success. So if group TMS value is 0, you're in the placebo group and you have just the intercept left. That is the log odds for the placebo group. And if we add together that intercept plus the slope, what we then get is the log odds for the TMS group, right? So, and as I just mentioned, if we then exponentiate the slope, e to the 0.8184, we'll get the 2.27 value that we had as the odds ratio.